Lesson 3, measuring devices. So what we're going to look at is choosing an appropriate measuring device, which is important when you're trying to take a measurement. Because, for example, if I went outside and I told you to measure the length of our soccer field and I gave you a ruler, it's going to take a while, right? Or if I gave you a meter stick and I asked you to measure the thickness of a dime. It's not exactly appropriate for the task. So there are several different types of measuring tools that you can use. A couple of these you should be familiar with. Tape measure. So a long strip of metal that can be marked in inches or centimeters or sometimes both. There's the rulers that I've lent you in class where one side is centimeters or millimeters and the other side is in inches. It's great for drawing straight lines and for measuring shorter distances. A trundle wheel. I have one, I'm not sure where it is, I'll try to find it. A trundle wheel, you count clicks. So as you're turning it, you can hear the clicks and you can count the click and each click represents a certain distance. Then there's micrometers and vernier calipers. We're going to look at vernier calipers more closely, but we're going to start off with the micrometers. Micrometers are used, they're precision measuring tools. They can measure outside dimensions or a thickness of a small object. That's what a micrometer can do. A vernier caliper can measure the outside, the inside, and the depth. So we're going to look at, there's, I don't think this applet works for the micrometer, but the ones for the vernier caliper work, and so you guys can actually go online and you can look at those applets tonight and get an idea of how they calculate the measurements. But we're going to start off with the micrometer. So I want you to turn the page and take a couple of minutes to look at the parts of the micrometer before I go through the reading of it.
I was just going to ask if I could go and talk to the news.
So let's start off with looking at the parts of a micrometer, and then we will look at the applet, which actually did load up. So the object that I'm trying to measure, I would put between the anvil and the spindle. So the anvil is a fixed point, and the spindle is what you'll rotate in and out to measure the width of that small object. Then you've got the sleeve, and then you have the barrel, and you have a reference line, which is this straight line that comes across. Your thimble and your ratchet. So the ratchet stop is used to even the pressure on the object to make the measurement more precise. So you turn the thimble, and then once you've turned the thimble enough, then the ratchet stop is my fine adjustment. So when we're doing course readings, what we look at is we look at the last visible line on the sleeve. So if I look at this on the sleeve, I've got 1, 2, 3, 4, 5, 6, and these are all half in between. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. This is the last visible line on the sleeve, which means I have a course reading of 6.5 millimeters. So if I was using a ruler, at best I'd be able to get to 6 millimeters. I wouldn't be able to get to 6.5 with any degree of precision. Then I look at the reference line. The reference line is on the barrel scale. So I look at where this reference line lines up with the barrel. So the barrel's 45, 40, and 35 is down here. So this reference line is closer to 39 than it is to 40. This barrel reading is 0.39 of a millimeter, so 39 hundredths. If I take that 39 hundredths and I add it to the 6.5 millimeters, I get a precise reading of 6.89 millimeters. So if we take a look at the applet, in this micrometer there's a locking lever which allows you to spin this into place and then lock it so that it doesn't move. So it's kind of like the difference between the really crappy compasses and the compasses that I lend you guys, that they have the locking so they don't move as you're trying to spin it. That's what this has. Oh, this side. So because of the mechanical advantage due to the fine pitch of the screw threads, so that's this part in here, your friction screw and the threading, you get a much more accurate measurement using a micrometer. So if I asked you to measure the width of your pencil using a ruler, you're not going to get as precise of a measurement as you are if you use the micrometer. So again, in looking at this one, the diagram is a close-up of a micrometer showing the thimble. The thimble rotates around a cylinder that has marking every ½ millimeter, which was like the diagram, only this one's a little bit clearer. So again, 1, 2, 3, 4, 5, 6 millimeters, and then every half. So again, this has 6.5 millimeters, or maybe it's 7 if this line here, if I could visibly see it. So it does say the upward line on the cylinder is barely visible under the thimble, but it is there. So then if we rotate the thimble 1 complete revolution so that it moves to the right, there's 6, 7, and now we have 7.5 because the downward thimble is barely visible. So it's looking at this part here on the thimble first, and then looking at the other part on the cylinder. So if I look at this one, the distance becomes 5, 6, 7, 8, 8.5. So I have 8.5 millimeters, and then if I look on here, I've got this lining up to the 12. So I have 8.5 plus 0.12, which gives me 8.62 millimeters for a final measurement. So if I move the micrometer, and let's say this was my measurement. If I wanted to take this measurement, I've got 5, 6, 7. So I'd have 7 millimeters exactly, plus this 0.25. So my reading would be 7.25 millimeters. So if I change this, now what I have showing is I have 5, 6, 7, 7.5. So I have 7.5 plus 14. So if I have 7.5 and 14 hundredths, together I should get 7.64. Is that kind of clear how the micrometers work? So let's look at a class example. So it says, determine the micrometer reading in metric units. So if I look at this first one, what I have exposed is I have 1.5. I don't know if I can see that. I don't think I can see the hard line there. Can you guys see the hard line? I don't think there is one there. So I have 1.5. And what am I matching up to on the cylinder? What is this number right here? 49. So that's going to be 49 hundredths that I add on to the 1.5, which together would give me 1.99 millimeters. So now if I look at the next one, we have 5, 6, 7, 8, 9, and I can see the hard line here, so that would be 9.5. And now if I line up that reference line onto the cylinder, where am I at? 9/100ths. That's the key to remember, is the numbers on the cylinder are in hundredths. So if I add these two together, I get 9.59 millimeters. So I want you guys to take some time and complete question number 1. So if we look at a vernier caliper can measure to the nearest 100th of a centimeter, which would actually be a 1/10 of a millimeter. So the micrometer is actually more precise, but a vernier caliper actually has the ability to measure more things, because with a vernier caliper, I can measure the outside dimensions of an object. So if this is my object, I can measure the outside dimensions of that object, like that. I can measure the inside dimensions of the object using the inside tool. Or I can measure the depth of the object. The little spindle that sticks out at the end, I can use it to measure the depth. So I do have more uses for the vernier caliper than I do for the micrometer. But again, it depends how precise I have to be in my measurements. Vernier calipers also measure in both units. I can measure in centimeters and in inches with the vernier caliper. Now, the vernier calipers that you have will always have a scale on them. And that scale is usually, let me see one of your calipers. Right at the end of this piece right here. So right on the end, there's written up at the top. So the one that I'm holding is accurate to 1/128th of an inch, or 0.05, so 5/100ths of a millimeter is the accuracy of this vernier caliper. So the top bar on the calipers that you guys have measure in inches, the bottom bar measure in centimeters. So when I am using a vernier caliper, we take the dimension of our object and we have it open and we're looking at this sliding rule. So we start off with the measurement in the bar. So the measurement in the bar is, in this case here, 6.1. We match it up with the bottom. So we look at two different things. The first thing that we look at is we look at where this bar is. So where that bar is, the reading to the immediate left is my starting point. So that to the immediate left, I have 6.1. So that's my hard measurement, or my coarse measurement, is this 6.1. So I'm looking at this sliding rule down here, and I'm looking to the left of that above, where that first increment measurement is. And I'll show you a better applet that might show a bit better. Once I have that 6.1, then what I have to do is I have to look at the sliding scale rule. And this is the harder one, especially with the copies that I have. Your textbook might be a little bit better at showing it, but I know up on here it's harder to see. What I look at is I look at these scales here, and I look to see which one lines up perfectly with the line above it. And in this example, it's right here, which is right in the middle. Or they have it going, or sorry, not right in the middle, it's one over. So this is my 6.5. It was this measurement right here that lined up. This measurement that lines up, it lines up on the bottom with my 0.05. each of these is 0.01, 0.02, 0.03, 0.04, 0.05. So I have the 6.1 plus the 0.05, so I get an overall reading of 6.15. And that's looking at it in metric. If I look at this in imperial, then I look at the top. So what I need to realize about my vernier caliper is I need to realize what each of these increments means in inches. So if you pulled it out and you looked at where 3 inches was and 2 inches was, you'd have all of these markers. Each of these markers refers to a 16th. The longer ones refer to 8ths, the shorter ones are 16ths. So this marker right here comes at 2 6/16 or 2 3/8. And then I do the same thing that I did down here. I look at where it lines up. And the line up here is right there, which in terms of this top piece ends up being to the 1, 2, 3, 4, 5. So this is the 5th notch, and each of these notches represents 1/128. So it ends up being a fraction of 5 128ths that I'm adding to the 2 3/8. The imperial system of using the vernier caliper, I will ask you to do on an assignment. I will never ask you to do it on a quiz or a test, because with the fractions it becomes a lot more confusing. I'll give you the metric ones to do on a test. So if we look at the next page, I think the caliper on the next page is a bit nicer, because this one is virtually the same as the ones that you have. So if we look at this bar again, between 0 and 1 inch, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 notches. That means each one of those notches is referred to as a 16th. And then I have these that end up, in this case, going 0, 4, and 8, which is 1 128th. So if I was looking at the 6, that would be 6 out of 128. If I was looking at the 3, that would be 3 out of 128. Does that somewhat make sense now? A little bit more? Yes, no? So if we look at this slider, because I think this one is a little bit nicer to look at. If we took the dimensions of our object, and this is where our object finished up. So what I have to look at is this measurement here is between 0 and 1, if we're talking about inches. How much between 0 and 1? Well, each of these notches represents a 16. So this is 16, 15, 14, 13, 12, 11, 10, 9, 8. So I'm at 8/16 or half an inch. Because remember, I look at the 0 and I go immediately to the left. So I'm at half an inch. That's my coarse reading. Then if I look at my sliding scale or my fine reading, I go up to this bar here and I look at where it lines up. The first place it lines up, which is right here. This is 1, 2, 3 128ths of an inch. So I'm now taking 1/2 of an inch and adding it to 3/28ths of an inch. And I can use my calculator to help me add those fractions, or I can change it into decimals at that point in time. If we were looking at the reading in the metric system, I go to this 0 and I look at the mark that's immediately to the left. 10, 11, 12, 13. So I'm at 13 millimeters. That's my coarse reading. Now I look at my sliding scale. When does my sliding scale completely match up with the notch above? Looks like it matches up right here, which is at 3.5. Remember, this is to the nearest 0.05 of a millimeter. So this becomes 0.35. So I have the 13 plus the 0.35, and I get 13.35 as a final reading. So let's look at these two examples. We are going to look at them in both imperial and in metric units. So the first one, I won't lie, is a bit harder to read just because the way that it has been copied and printed. So I think we can do this. We can get this done. This is the line that we look at, and we look at what's straight to the left, which is this marker right here. So now I have to figure out, what does that marker represent? Well, 4 is represented right here. So if I count backwards from 16, because each of these is a 16, I have 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. So this would be 3 and 6/16 would be my coarse reading. And then my fine reading is I look up here at this scale, and I look at where does it line up? Where does the top part line up with the bottom part? So where do I get the best line up here? Right there, which is at 7. 1, 2, 3, 4, 5, 6, 7. And that's 7/128. So then I would use my calculator. I'd ignore the 3, and I'd go 6/16 plus 7/128, which gives me 55/128. In metric, I'm looking at the bottom one. So this is my line that I start off with, and I go immediately to the left. So immediately to the left is this mark right here. What is that measurement? This is 9. So this would be 8 point, right. And then I want to look, when do these bars start to perfectly line up? So they don't, it's not quite perfect at 1, but it looks pretty darn perfect at 2. And that is actually 2/100ths, because my accuracy is to the nearest 100th of a millimeter. So if I take 8 6/10 and add it to 2/100ths, we get 8.62 centimeters. And this would be inches. So what I want you to do is take a moment and try to do the reading on this caliper, and then we'll look at it together. Okay, let's look at this one in inches. So again, this is my 0 marker, so I go to the straight left of it, which means it's less than 3. And if I count backwards from 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. So again, I get 2 and 6/16.
Will you get 10/16? Or no?
No, because it's the zeros here. So it's to the left of the 0, not of the 8, of the 0. Then I match up across the top. Which one seems to match up? The 2? I get the 1 matches up. Does the 1 match up, or does the 2? What do you guys think?
2 looks closer.
2 looks closer?
Yeah.
Okay. So 2 and 128. So when I add these together, what do I get?
2 and 25/60.
I got it. If you used 1/128th, your answer, your simplified answer is going to be different.
What did you get on the?
Okay? And when I look at them, if you said 1/128th, it looks it looks very close. I probably would have allowed either one of them. If you had said 4 or 5, those aren't even close, right? So if it could be one or the other, I'll give both answers. So now if I look at the millimeters, again to the left, I'm at 60. And which of these lines match up afterwards? The, which one? The one, oh, right here?
4
Oh, the 4?
and a half.
Oh, yeah, it does. So this one lines up better first.